Hello and good day, everyone, and welcome to this Gradle webinar. I'm your host, Oliver White, and joining us today for Observing Build and CI Productivity in Your Favorite OSS Projects is my colleague, Gašper Kojek. Gašper is a solutions engineer at Gradle, coming to us from the beautiful country of Slovenia, where he spends his workdays helping our customers best accelerate, troubleshoot, and observe their builds and tests. Now, I would find it kind of hard to believe if there's an engineer listening to this right now who isn't using open source technologies at work. But did you know that if you use technologies like Spring Boot, Kotlin, Apache Kafka, Testcontainers, Android X, and about 20 others, then you're using open source software that leverages our full Develocity platform for free. And from this, they get to accelerate their builds and tests, as well as deep toolchain observability into failures, flaky tests, dependency management challenges, and more. So in this webinar, Gašper is going to review insights gained from the publicly accessible data of over 50,000 OSS project builds per week. We will take a look at how different projects leverage build and test observability, common patterns we see in build and test failures and performance regressions, as well as show some live demos exploring the build data. Now, while we wait for everyone to get settled with their coffee, tea, fizzy beverages, etc., we've got a few housekeeping items to go over. Today's session is being recorded so that it can be shared with you next week. It will take about 45 minutes, and we'll of course have time for live attendees to do a Q&A afterwards. So please send your questions early in the Zoom chat or to me privately, and we'll do our best to address them at the end of the session. Lastly, this webinar and all of our DPE events are made possible by the support from our hundreds of happy Develocity customers, including Reddit, one of our favorite websites, no doubt. They are looking to hire a staff systems engineer remotely in the US. Check out redditinc.com/careers for details. Okay, that's it from me. Let's hand it over to Gašper. It's great to see you, sir. Thanks for joining us today.
Yeah, thank you for the intro. Hello everybody. Good morning or good afternoon, depending on where you are. And yeah, as Oliver said, my name is Gašper. I've been helping customers improve their build times for the last 2 years as part of the solutions team here at Gradle, which is the company behind the Gradle build tool, obviously, as well as the Develocity platform, which is what we'll be kind of using to observe the build time and CI productivity in your favorite open source projects. Just like a quick intro on Gradle itself. So it's, Gradle as a company, as well as the Gradle build tool, is deeply rooted in the open source world. Like first release of Gradle build tool was in 2.9. It's open sourced. We have more than 50 million downloads a month, and it's the most used build tool by new open source projects on GitHub. So I'll start with a question. So, like, what do these foundations have in common? And kind of Oliver already mentioned that. So they're all using Develocity to speed up their builds. And before we kind of dive into that, let me first give you some context. So time is precious. We all have more things than that we want or need to do than we have the time available. And so it is really crucial that we make the optimal use of our time to have the most impact and to be the happiest. I'm primarily referring to work here, but I think it also translates also quite well to private life. We as developers are the most productive and also the happiest when we are in this state of flow, as we kind of call it, when we're fully immersed into what we're doing and the task at hand, and that's when we create the highest value, the highest quality, and we deliver that at the fastest pace. The reality is often disappointing. Like in reality, it's quite different to developing in the flow. As we're often waiting, we're context switching, we're like wasting time with inefficient troubleshooting, we're Googling for answers, and we make many gut feel decisions about like what's wrong with the build and so on. So, I mean, it's in general, I think it's safe to say that the toolchain behavior is both a major contributor as well as an inhibitor to developer productivity. And if we look at it just on a second in a bit more detail, so let's say that you're building your software, you made a change, you want to see that if that change is sound, you can build that like from the IDE or locally from a command line, or you might push it to CI and then have CI do your work for you. But the bottom line is that like after you do a change, you need to wait to get the results, and sometimes it just takes too long to get that feedback. You might make a little change, and you have to wait a long time to see if it builds or if the tests pass, and so on. I think we've all experienced this quite often, and it's like, yeah, that's one example of like high friction. Another example would be like, okay, so something is broken. Now it takes a really long time to troubleshoot and to fix it. You made a change and you run the build and the test fails, and you're like, oh no, okay, like here we go again. You start investigating. Sometimes, yes, it's a direct correlation between the change you made and the error you see, but sometimes it might be just a flaky test that has nothing to do with your change per se. But you should not have to like figure that out yourself. Perhaps like the test has been flaky for a couple of weeks now. It's been known to some developers in your team or like another team, but it's not been made like publicly observable. It hasn't been surfaced. So again, like you wasted time and all in general, like all these frictions like make you slower in delivering features. Typically the quality is affected too because of that. And if you multiply that over the year with all the engineers, with all of the CI builds in your team, and it doesn't matter whether it's a CI, whether it's a commercial project or an open source project. At the end of the day, like you're wasting time just waiting on stuff to happen while you just sit around and do nothing, basically. And that's really the problem at hand. GitHub actually GitHub does this service every year, but they usually ask something along the lines of what is the most time-consuming thing in your work. And obviously, besides writing code, it was usually waiting for code to build. Or to debug like what's going on. And if you think about it, it's quite ironic, especially the waiting part, because I mean developers are well-paid engineers, and the big part of that salary goes to waiting. So it's kind of not ideal, right? And if we get back to like these open source foundations that are using Develocity, so we have like some are bigger, some are smaller of the projects that Develocity supports. So, for example, we have Apache with 350 projects. Micronaut has around 80, I think. Common has 40 to 50. Spring is also around 80. We're also working with Eclipse to enable their like 400 plus projects to use Develocity as well. We're very excited about that. And yeah, you might ask, so like, what is Develocity? So Develocity is a platform that helps you improve the productivity of engineering teams, as well as provide deep insights into how the software is built, both locally and on CI. And so that might be like where the time is being spent, which dependencies are you using and stuff like that, as well as it's offering some highly accelerating technologies to accelerate the execution of your Maven, Gradle, Android, Bazel, SBT, and NPM and Python builds, where like NPM and Python are coming along. We just added support for that. And if we focus first on the build insights, we give you these insights via build scans. That's how we call them. So a build scan is generated per build. You can think of it basically as an X-ray into your build. And it gives you the information about what's going on actually in the build itself. So it gives you the resolve dependency graph. It tells you like which tasks or goals, depending on which build tool you're using, were actually executed, as well as like if they're not, are they up to date? Are they coming from cache? How long they take, and so on. Same thing for tests. It gives you like the applied plugins and their versions, switches or flags, the environment, some environment kind of information, as well as the CPU and memory usage. Gives you the full console log, which is also searchable, and many other things. The neat thing about all of that is that it's linkable. So if you're trying to troubleshoot something, you're not sure like how to proceed, it's very easy for you to like link to a specific, let's say, line in a console log, or like the failure itself, send it to a teammate, or in case of open source projects, you can also send it, for example, in a PR. Okay, like why is this happening? This shouldn't happen. And it's much easier than like copying the full console log. Then you might have some back and forth. Okay, like which JVM are you using and stuff like that. That's all in the build scan, for example. Another thing we do is we offer build insights via cross build analysis. So here we have 4 screens. Top left is the build trends view. It shows you how the build times evolve over time. We'll show that in a demo with one of the open source projects. I mean, all of these will kind of show it in a live demo. Top right is the performance dashboard. It exposes, for example, degradation in cache usage. It also gives you like information about dependency downloading and stuff like that. Then you have like in the bottom left, you have the build scan comparison tool, which can reveal the root cause for unexpected cache misses. So for example, you're building or your CI build is building the same commit twice for whatever reason, you would expect to get cache hits on that. And if you're not, like this is the way to kind of troubleshoot that. It might be that it's like a time step generated somewhere that's causing cache misses. And then the bottom right is the failures dashboard, which can reveal like the most common build issues on CI, as well as developer machines. And that can also be super useful. For example, I think we've had one case where somebody found out that they had like on a specific CI machine, they had a failing disk that was causing some build failures. And they used this view to kind of figure it out, because you can see like you have affected hosts there as well. So that's one thing, as well as another thing is the Develocity reporting and visualization tool. So this is a platform for data exploration and analysis with customizable visualizations and reporting. Under the hood, it uses the local NCI build data that's available in Develocity. That data is then fed through a query engine into Grafana. In Grafana, we supply multiple pre-configured reports, and these allow you to do like cross-project analysis. And this is especially useful with like other open source foundations, for example, Apache, where they have a bunch of projects. It might not be that simple to say, okay, like what's taking the most time on CI, for example, and this is a way a tool to kind of get that. If we move on to build acceleration technologies that I mentioned, that the open source projects also use, obviously. So we have the build cache, which I already mentioned. In general, like the build cache, how it works, it basically it stores and then it provides artifacts produced by the previous task or goal execution to avoid work that's been done before. You can do that either with a local build cache or remote build cache. Remote build cache is super useful for ephemeral CI builds, for example, GitHub Actions. And how it works is it keeps track of the inputs to different tasks or goals. And those inputs are not just the source code, they're also like environment variables, JVM version, a bunch of different properties. A cache key is calculated from those, and if that cache key is available in the cache, it can get basically the output of that, and you can just keep executing the whole thing. So that's the build cache. Then we have predictive test selection. That runs only those tests that are likely to change their state based off of like the changes that you did. And the decision is made based on historical data and machine learning applied to the data. Then we have a simulator for functionality as well to assess like the feature's effectiveness. And then the last thing is the test distribution, which takes your existing test suites, your classes and the tasks and all of that, and distributes them across remote agents to execute them faster. Now, these test agents can be auto-scaled up and down. The neat thing about it is that you can also use it with local agents. And since it has all of the history of how long different test classes, for example, take to execute, it can make those partitions much more intelligently so that basically the total build time is as short as possible. And so I guess like the next part of this is basically we'll just go to some live demos with these different open source projects. So we'll start with caching itself. So this is the Testcontainers open source project. And you can see here, like, so their average build time is 42 seconds, and they use remote build cache enabled by Develocity to save basically on average over the last 28 days, they save on average over 90% of basically execution time. So you can see how this can be valuable. And here we're looking at the performance dashboard, so you can see like different things here. Each of those bars is one separate build. Yeah, a similar thing. We can also look at the JetBrains build, so the Kotlin build. They also like they have they do like 530,000 builds per month. Which is like a very high volume. So you can see like on a weekly basis, this is around between 100 and 130,000 builds. The average build time is 12 minutes, and they also use Develocity to cut down that build time as much as possible. through insights, through optimizations, as well as caching. So, for example, here we can see the avoidance savings are on average, like over the last 28 days, are 38 minutes and 32 seconds. And then you can see here also, like roughly half of that goes to up-to-date checks, half of that goes to remote build cache. And you can also see like how this might move through time. So if you're interested, for example, in the average values, you can see like it's hovering right around 38 minutes of basically saved time on average on every build. And we can go into more detail. So, for example, like if we use the Kotlin build, one of the builds, functional test is the test they executed. You can see, like, for example, this build here took 6 minutes and 28 seconds with 28 minutes of execution time saved. If we go into more detail now, and yeah, just to point out, so this we're looking at a specific builds, kind of like of one specific build for the Kotlin project. If we go into the performance view, you can see here that those 28 minutes, that's 55% of the time. One thing to note is that the 6 minutes and 30-ish seconds, that's work log time. These savings are in serial time. So the rough translation here is about divided by 4, since that's the serial execution factor. That's like a ballpark estimate. But still, basically, this means that without avoidance savings, this build would have taken like 12 minutes and a half, maybe 13, like a guesstimate here. And we can go into even more detail. So for example, if you're interested in like which tasks came from cache, you can click on this and you can see all the tasks that came from cache. In the timeline view, which is where we're at now, you can also see like, okay, so why was this not up to date, for example? And you can see the reason here, as well as you can see, okay, so they didn't have this exact cache key in the local cache. However, they got a hit on the remote cache. And afterwards, they also stored it in the local cache so that the next time they execute, local cache can be hit, because I mean, local cache is always going to be faster than remote cache. Or you might be interested in like which tasks were executed and which were cacheable. So this also gives you all of that information. Now we're just looking at a random build, so that doesn't really tell much whether that's good or bad. But if you did this in a control environment as a part of experiment to verify whether your build is like cacheable or not, and you got something like this, you'd say, okay, like I would expect this to come from cache and not be re-executed. Yeah, if we check, for example, this is the Apache Camel build. It's a Maven build, just so you know, same thing, like caching works just as fine as with Maven as with Gradle. This build took 23 minutes, but they did save 25 minutes of build time. And if we go into performance and goal execution, you'll see that here, since this is as with most Maven builds, they usually run in serial time. They don't do work in parallel. These 25 minutes are actually directly translated into the build time itself. But if we are more interested in, if we go check out the dependencies, for example, so we're now in the dependencies view for a build scan for the Camel Apache Camel build, and you might be wondering, okay, like what's the versions that they're using? This gives you all of this information for the different phases of the build for all the different projects. You can see like they have a bunch of dependencies from a bunch of different projects, from a bunch of different repositories. And it's, especially with bigger build, it's not that easy to kind of see what's the version of dependency that's actually being used. So for example, here, this is one example where it shows that this exact dependency was requested with 2 different versions. And so dependency, like version resolution needed to happen. And even though here it was requested as a transitive dependency of this thing, as version 2.0.0, it was resolved at 2.1.0, since that's where somewhere in the project that's what was defined. And you can see like where that was defined here in the details pane of this. And obviously you get a very similar view for Gradle builds as well. The only difference is that you're not having different phases, but you have different configurations to kind of look at. Another neat thing you can do here is also to search for different dependencies. So for example, you might be wondering, okay, does the camel have the log4j dependency somewhere? And yes, it does. You can see it's in all of the projects under the test phase. You can see like which version it's on. And And I mean, I hate to be like using Log4j, the vulnerability a couple of years ago as an example, but it's a very good example, and it's very easy for you to check whether they're using the fixed version or not. If we move on to like some tests, which are also like often very kind of expensive to run. Here we're looking at the Apache Kafka project, which can be seen as here is this filter applied. We're looking at the last 7 days of test data. And you can see they have some builds with failed tests, as well as a bunch of builds with flaky tests. Now, by default, this comes the list below, which is the list of test classes by failure. By default, it comes ordered by failure rate. And we can go into like this specific test class in more detail. You can see this is being applied here in the filter. And you can see, okay, like if I just fix this one test balance partition leaders test, that's the most failures that are coming from this test class. And so that's also like Apache Kafka, how they're using these dashboards. If I go back to the tests view, if we now focus on flaky tests, you can see, okay, like we can check out the custom quota callback test, for example, the filter is applied there. You can see, okay, there's two tests inside there that are both kind of equally flaky. But you might also, we can check another one and see if there's something else because oftentimes it comes down as like one test being the flakiest and then like some training ones. And so you can see here, for example, they can use this data to say, okay, like if I just fix this one test, I'll have eradicated 33% of the flakiness from this. I mean, in 33%, this is not going to be flaky anymore. So it's very useful data. It's very actionable data here as well. And that's how it's being used as well. If you move on to build failures as such, so we're now looking at non-verification failures for the Android X open source project. And you can see there are some failures here. And it's actually quite often, you can see like it's 46% of builds that have non-verification failures. And so you see here, okay, like we have some dependency resolution failures for the core view tree dependency. This is basically the same thing. And yeah, if you click on that, it will take you to a more detailed view for that task, for that type of failure. Okay, so we have some canceled builds. We have some Metalava failures. Metalava is a Google thing for API kind of management and testing. And yeah, you can use this and get insights into where is this being run, and so get some actionable insights here as well. So, I mean, since this is an open source project, most, if not all builds are going to be from CI anyway, because only the project's committers have access to publish build scans from the local machines. But in this case, you can see like, okay, this is happening on CI. It's happening both on Linux as well as on macOS. So, it's not like operating system related. And then you can dig deeper into this information. So yeah, that's for the build failures themselves. And then the last thing I want to show you is the predictive test selection. Now we're looking at the Spring Boot build from the Spring Foundation, obviously. And we're looking at the simulator. You can see here that, if they had like 1,000 builds with tests in the last 7 days, and if they applied the predictive test selection, they could have saved up to 52% of test execution time, which, I mean, since tests are usually the ones that take the longest, that's like a very significant thing. If you want to look at like a real usage, we can switch to the Apereo project, which is also open source. They are using predictive test selection in production. And after all of the caching and all of the savings they get from caching, they could still save an additional 10% of test execution time. They do save additional 10% of test execution time, which comes out almost as 7 days in the last 7 days. So those are like very actionable and very real savings that all of these open source projects have. And yeah, the last thing if we go back to the presentation, the last thing that I wanted to mention is the test distribution. I don't have like a live demo of that since it requires some additional infrastructure and stuff like that. But yeah, the Eclipse, we did some tests, and the Eclipse Jetty project could reduce their test time from 47 minutes to 16 minutes thanks to test distribution. And with additional optimizations, they could reduce their total build time from 51 to 11 minutes by enabling build caching and parallel goal execution and test distribution. So all that together could reduce it from 51 to 11 minutes, which is like a very, very nice thing to see, right? And so if you go to like, why is like all of this, why is all of what I've been saying, why is that important? Basically, if you have faster feedback cycles, you have less, obviously, you have less idle or you're waiting just less for stuff to happen. Because you're waiting less, you have less context switching. For example, if your project builds in a minute, you're probably just gonna wait that minute. If it takes 30 minutes, you're probably gonna go do something else, and you come back and you see that something's failing, and it just goes into a whole that cycle. And if you don't need to switch the context, you're much more focused. You are much more productive, and you like kind of do like the output is of better quality. On the other side, if you have like super fast build, you tend to build faster or more frequent. You tend to like run the tests locally as well. There's fewer downstream incidents. Your like smaller change sets and stuff like that. And that's also, all of that applies also to open source projects, as like kind of we've seen here. Because like developers, we have many projects to choose from in the open source community that you can contribute to. And you can decide based off of popularity or relevance or tech stack or community or whatever you might be. But it's still important for those open source projects to like provide a first class developer experience. And that means that like the build should be easy and fast. Testing and running the project as well. It should be like, it's very good if you can be very efficient with fixing errors, as well as to unblock once yourself. For example, if you open a PR, CI fails for whatever reason, it's very easy if you can fix that yourself. And it allows effective collaboration with the committers as well. As I said, like all of the build scan functionality is linkable. So it's very easy to ask for help in that regard as well. And another thing with open source projects is, I'm sure you've also experienced that, for example, you check out a project, you want to build it and it fails, or it's taking like a super long time. That's also not something that you want to see, like the first thing you want to contribute to an open source project. And yeah, you can use build scans to like fix that, or identify flaky tests, which are also like a quite an annoying thing to experience. And yeah, like Develocity is kind of enabling all of these different projects. So here's a bit more. So we have obviously like the Apache and Micronaut and all of those. We also support JUnit and Kotlin and Hibernate and Redpack and XWiki and many more. Quarkus as well is quite a prominent one. So yeah, that's kind of it actually. I think I was speaking too fast.
Well, yeah, you got through it about 10 minutes faster than you were predicting, so that's good.
Yeah, just means that we have more time for questions and answers.
Yeah, I have a couple sent to me directly, and folks that are in the webinar chat, add your questions in there. We'll get to that in just a minute. So thank you, Gašper. This ends the presentation side of our webinar today, and we're going to go to the Q&A. If some of you have to jet, that's fine. I wanted to just leave you with one final comment. If you're here, then you've gotten to be a little bit familiar with what we do, but perhaps you haven't taken the first step towards actually using some of these technologies. What we'd like to do is to invite you to a guided trial of Develocity. And this is where you spend a few weeks working hand in hand with our experts, where you'll be able to prove an actual ROI and show opportunities for speeding up your builds and tests, troubleshooting faster, and just getting good observability into everything that goes on in your entire build toolchain. So I invite you to go to gradle.com/develocity/trial to find out more, and, tell them Oliver sent you. All right. First question. It's actually about the avoidance savings, and it's kind of related to how do we determine how is Develocity able to determine what is cacheable, what can be cacheable and what can't, and then how does that kind of roll up into the avoidance savings metric?
Okay. Yeah, so it's in general, it's not the Develocity itself that's deciding that. With Gradle, it's the author of the task that kind of decides whether they're going to make that task cacheable or not. With Maven, even if you author your own task, if you have a custom task, you can also make it cacheable. You need to define all of the inputs that affect the output. You need to define which outputs are there. And then you just say, okay, like this is going to be cacheable. And with Maven, for example, it's a bit different since Maven itself doesn't have caching. I mean, I know it has like with Maven 4, and that's been backported as an extension to Maven 3 as well. But for Maven, the Develocity extension, which is added to the project, kind of takes care of that. But it's not done automatically. That's done for a bunch of goals or modules by us. But you can also, again, you can configure your own, or like if you're using like a plugin that's or extension that's adding some custom modules, you can do that as well. And that also reminds me, one thing that I forgot to mention is basically how this integrates into the build. Both, and that works the same way for open source as well as for closed source projects. So basically, it's a Gradle plugin or maybe an extension or plugin for the rest of the build tools that you apply to your build. Configure like, okay, I want to reach that server. Configure a bunch of different things. You can add your custom data on there. For example, whether that's a pull request, or you can link it to a specific CI build. And stuff like that. And that's also visible in all of these build scans if I switch to one of those. So I guess that's one of the bad ones. But if we check the Kotlin one, you can see, okay, like you have some GitHub source. It was done locally, command line, Linux and stuff like that. But if I go back to like how that's decided, in general, it's so if a task or goal is mostly CPU bound, then it makes sense to cache it. If it's mostly disk bound or IO bound, if it's downloading stuff from the internet, then you don't want to cache that. If it's just moving files around, for example, a jar task or a goal, that also mostly doesn't make sense to cache, since caching is also just going to move files around. So you might just execute it in the first place. But those are kind of the general guidelines on how we decide which stuff should be cached and which shouldn't. Or like what makes sense to cache and what not.
Gotcha. So in your experience working with pretty much developers every day, would you say that's already considered a best practice for most teams to make cacheable anything that can be cacheable? Or do you run into instances where, that hasn't been considered yet necessarily?
So if the teams that we're working with have done that already, I mean.
Yeah. Just in general, is this? Would you call this a best practice that most development teams are already doing, or is that maybe not the case?
So if we for Gradle, since that's usually, since that's supported natively, it's quite rare to find a team that has caching disabled. But often they don't have it. They don't have remote caching set up, which is what the Develocity brings. For Maven, it's very rare to see a team that are also, as well as for open source projects, it's very rare to find a project that's using caching already. Since, for example, you need to use the Maven 4 or Maven caching extension, you need to set it up. For example, we're working with Eclipse. I think for now I found one project that does that. So for Maven, it's very rare that they use caching, but in general, it's like, it is a best practice since you're just avoiding work that's been done before. For example, if you're compiling something, you just get the jar or like the classes or whatever the output is. For tests, you get the test reports and just skip executing all of those tests and stuff like that. So it's super useful.
Okay. Great. Thanks for that. Thanks for that context. We have a question from the audience. When predictive test selection incorrectly avoids a test that should have actually run, how do we work that out in the end, and how do we make sure that doesn't happen again?
So as I said, if a test is kind of mispredicted, basically, there's a couple of different things that can happen. But if we take the kind of the worst case where it kind of leaks through to if, for example, if that is set as a check on a pull request, and that gets merged to the main branch, one of the things we usually recommend is to have a post-merge job or a nightly job or something like that, where you actually run a predictive test selection in remaining mode, which is the mode where you basically execute everything that hasn't been executed yet for those specific set of inputs. Basically, that's what kind of says, like it executes the remaining tests, the ones that have been skipped before. And so that will catch it. And the machine learning, since it knows all of the history of all of the things, it knows which inputs were kind of what the inputs look like. And it says, like, I guess this inputs that was a bad prediction. It kind of autocorrects itself.
Gotcha. Thanks for that answer. Another question. When it comes to build scan data, do we have a report somewhere that condenses all the possible improvements that could be immediately addressed to improve build performance?
No, there's no AI thingy yet that would kind of analyze the whole thing and tell you what you can do, what you should do. The thing is that's also we could do that with in a controlled environment. So if you're running from two exact same source sets with no changes in between, then yes, it's very easy to say, okay, like any cacheable cache miss should be fixed. Very easy to say. If you're just looking at the random build scan, such as we are, like for example here, this is on a separate branch. You don't know what the changes were there based off of like all of the things that were in cache, for example. So it's in just looking at random scans, it's kind of not that easy unless you have some additional context about your CI setup and stuff like that, where you know, okay, like I'm doing a pre-build, like a seeding build somewhere before. I know that this should have been a cache hit. So yeah, but to answer your question, there's no like functionality which would kind of tell you what you need to do directly.
Gotcha. Final question that we've got is about test distribution. Does it work with Kubernetes, and does it work with Kubernetes only, or are there other orchestration engines that you can use?
I mean, you can set it up with pretty much all of the major cloud providers. You can also, you don't need to, you can also just have 10 physical machines, get the remote test executor software running on those, connected to Develocity, and that's it. No like orchestration or anything. So it's not tied to a specific thing. But for auto scaling, it works with Kubernetes and like all of the cloud providers that use like basically Kubernetes architecture. I would need to check the documents if you can use it with a different thing for auto scaling specifically. I mean, without auto scaling, as I said, like you can set it up on your personal laptop. You could use that as a remote agent if you wish to do so. I wouldn't recommend it, but you can do that.
For the brave among us. All right. Well, thanks very much, Gašper, for your time and expertise today. And thanks to our audience for joining us. Stay tuned for more webinars coming in the next couple months. We're getting some really good ones down the pipeline. And in the meantime, if you haven't checked out DPE University yet, it's a good place to go to learn more about optimizing Maven and Gradle builds, learning more about DPE, how to use Develocity to solve some of your problems, and so on. And many of these courses come with certifications afterwards, so you can brag to your colleagues. All right, that's it for today, everyone. Thanks for joining us, and enjoy the rest of your Thursday. Thanks, Gašper.
Just one sec. I think there's another question that was posted in the Q&A.
Here we go. Oh, well, better late than never. Let's keep going then. Is Mark Romero asks, is Develocity secure? Does it clone the repo, or is it just displaying build content?
Okay, so Develocity itself is an on-prem installation, so it's installed on your infrastructure. It doesn't clone the repo or anything like that. It hooks into the build tool to gather metadata. So it gathers like where the time is being spent on, like which dependencies and stuff like that. However, it doesn't actually upload the source code or anything like that to Develocity. And the only thing that Develocity kind of does to reach out is to check the license, but even that can be configured in an air gap mode. So it can be totally like offline, basically installation without any network activity other than obviously you need to be able to connect to it to publish scans.
Okay, great. Another question is, can analysis happen for the same build using multiple build tools? For one commit to have multiple builds that are aggregated. I'm not sure if I don't know if I fully understand the context there. Maybe you do.
I think so you can add, and that's what the common custom user data, like maybe an extension Gradle plugin, SBT plugin do. You can add git commit as custom values, and then you can filter on that. So for example here, so I just clicked on the link that was added by CCUD. This is the Kotlin instance. And so we see all of the builds that were done with this random git commit ID, with all of the different requested desks. If there were like different build tools, like if there were some Maven builds in there, those would also show up. And then you can see like the performance or the trends metric on this specific build. And you can see like for this git commit ID, they did actually 321 builds. Mm-hmm. And you can do, trends I think wouldn't really apply here as much, but you can get here like, okay, the build time, the avoidance savings, you could filter it by build tool, but since this is only using Gradle, it will just like, it shows Gradle here. If you had like multiple build tools, you could filter it for one specific. I hope that kind of answers the question.
Yeah, I think that gets to it. Another part, do you have support for using custom build tools as long as the client can transform data into a specific format? I've never heard that question before, actually. What do you think?
No, we don't have like custom build tool support, but we are exploring a way to possibly do that in the future. And I think that also answers the third question from that, which is any plans on supporting Make as a build system. I'm not aware of any plans for Make specifically, but as I said, like we're exploring options on how to kind of make it make a more generic possibility for including other build systems as well.
And also, if folks are not aware, we have kind of maybe a little bit past beta support for some build scan functionality for NPM and Python as well. So we are in the process of expanding our support. Make isn't on the list as Gašper said, so we'll keep that in mind. All right, well, I already did my my conclusion and goodbye, so let's just end it here. Thanks, everybody.